Hi, this is Cententos May, and today we're going to discuss why rectangles are better than circles. Now, in what sense do I mean this? I mean this as in operating materials in the industrial workforce. So, let's start with something like a gold bar. So, here we have a normal gold bar. This is what it looks like on the front. Now, what's the problem with this gold bar as you can see it right now? These rounded edges. Now, why is this bad? Well, the reason this is bad is because this makes the absolute weight in this gold incalculable. Now, why is this? Well, let's begin our talk. So, right over here I'm going to draw a rectangular prism. It's not the best. After all, I am holding a big iPad in my left hand, so. And here we're going to draw a cylinder, which is pretty much the same as the rectangular prism, except that its base shape is not a rectangle, its base shape is a circle. Now the thing about this shape over here is that you can calculate how much amount of gold is in this bar, but you can't calculate how much is in this. Now what is the reason for that? Well, it's thanks to a little number called pi. Now if you want to calculate the weight of this, you're going to have to use pi. You're going to have, figure out the diameter, you're going to have to get the radius squared, something like that, get the length, and then you'll get the mass. But that calculation has to have pi as an integral part. And that ultimately fails because you can't calculate pi. Now, you could get a close approximation, but you can never actually get pi. And this is proven because pi is transcendental. For example, for most of human history, people thought this was pi. This is wrong, however, because it only gets the first few digits. Now, once people started looking more into pi, they started realizing, hey, we didn't get all the digits right. So that was a large problem. And they came up with bigger fractions and bigger fractions and bigger fractions until they can really come up with a fraction for pi at all. They could only ever guess. So, that is why it's bad to use this. Now, I am aware that there are advantages to using this, just as stacking, etc. Well, I'm going to talk about some possible, better solutions to this problem. First off, a hexagon shape. Now, why is a hexagon shape better than a circle shape? Well, because it does the exact same stacking properties that a cylinder can do, only that you can calculate how much is in the hexagon. Sorry, cough. And also, it has a nice little rolling ability. Now, you can also do this with an octagon to get better rolling ability, though it's less calculatable and it's less stackable. Here's a solution, however. So let's say you have a square prism right here. And what you're going to do with that is that you're going to take the diagonal of this, you're going to add 1 to each of these sides. So pretty much the square root of this plus 2. And then you're going to make a circle around it with a cheaper material. So basically you have an insignificant material that's right on this, and inside you have the material of which is valuable. So let's say you make this out of wood and it's holding gold. That would be perfect because wood is a renewable material, its price influxes all the time, so you don't really need to know the weight of wood, but gold is limited, and thus it is at fixed prices mostly. So you're going to need to always know the weight of gold. And so you put in things like this so that you can easily transport it. And in ways, this is pretty much how barrels work. You design the barrel to hold a certain weight, and then you roll it so that you can, move it. So, yeah, that has been my talk on why rectangles are better than circles, in the material sense. This has been Cententos May. Have a good day.